All right. Welcome. This is the Bridgeport Linux User Group. My name is Ray. Today we're going to be talking about OpenShift and what it could potentially do for you. Or maybe that you just wanted to play around with it. I'm so confused with what to do with my hands.
Yeah, put them in your armpits.
Yeah. So what is it that you know about OpenShift?
I know that OpenShift is, as was explained to me by someone far wiser than myself, sort of a combination or an infrastructure for Docker and Kubernetes.
Okay.
I guess a framework used to utilize them both.
Yeah.
Okay.
So what this is, right now, my own home lab, everything is down. We're doing renovations and I didn't want it to be all torn up, so I turned it off. This right here is OpenShift Online, right? For just someone wanting to play around with it, there's a free 30-day trial, and that's exactly what this is, right? There are quotas that are set, and I'll demo those here in just a little bit. And the product actually does that itself. There are quotas that you can set, and they'll enforce them and tell the end user that you're getting close to your CPU cap or pod cap or whatever, and you'll see them whenever I start reaching the upper limits of those. But basically, this is just so underneath is Docker and Kubernetes, and they work in conjunction. And this is the orchestration piece that goes into all of them, right? So instead of you having to sit down and type out Docker files and Kubi control files and stuff like that, or Kubernetes files, this will streamline some of those applications, right? Does that mean that you can't necessarily do a custom container? Absolutely not. You could pull your own container and then you could push it into the internal registry. You can then deploy it as an image, right? So up here, if I wanted to add to my product or project, I would deploy a new image. This one isn't hooked up to do anything outside of what it does right now, but this would give you create an image pull secret. You can give it an image name, and you can ask it to pull it for you, right? In the more broad scheme of things, you can set up image streams so that you can pull from specific registries. Nexus, Nexus and Quay, along with some other registries, right? Satellite is also one of those that you can pull from. I would not recommend using Satellite as your registry. Anybody from Red Hat's watching? I didn't say that. But it's true. It makes it very difficult. OpenShift wants to be natively connected to the internet, right? It wants to be, right? Because these are the things that you're pulling in. You're pulling in images that someone has created, the containers that OpenShift uses, right? So it's all layered in there. The images themselves have layers. So as you add to that particular image, it makes a new layer, right? The more layers you have, the bigger your image is, right? So it might impact your deployment or whatever, right? So you want to kind of keep those to a minimal if at all possible. One of the coolest things that I think, and I'm going to shift into the application pieces. One of the coolest pieces of OpenShift is its dynamic capabilities, right? So a lot of us have been in those environments where you do a full application and you're rolling this application out to, say, 20 servers, right? And that's application is load balanced in there. What happens when you need to do a rollback, right? Well, with those particular software, you either have a backup and recovery solution, which is, a little scary sometimes, or you have to re-image all of the systems, and that's very scary, right? To put your new application or uninstall and reinstall your application. With OpenShift and doing these containers, rolling forward and rolling back is a matter of a couple clicks, right? So right now we've got the blue demo, right? He's up and running, and we have the green demo. And one thing I want to talk about is the way that OpenShift abstracts a lot of that information, or a lot of the manipulation pieces to your applications, right? So these are literally web applications running out there in the wild. I took orange away just to show you what happens, right? So there was a third application down here, and we'll put them back here in a minute. But the blue and the green application are still there and they're still functioning, right? Orange is not, right? So I'll show you the orange page, and he's not functioning just like this one, right? And what that is those are a route that I had set up a minute ago to route my traffic in to a specific application. And what I'm going to select is this blue-green demo, and I'm going to edit that application or that route, and I'm going to put it back to one of the services that I actually have running, and I'm going to set it to blue, and I'm going to save it, right? So just a minute ago, we had an application in a critical production system that stopped responding, right? And I don't know why. Do I have time to troubleshoot it right this second? I might not, right? But what I did was I went in there and I flipped it over to another route, and I have my application back online, right? So the ramifications of this are whenever you're doing those application deploys and everything starts going wrong, right? But you know that you have a known good environment that is currently running, and you could process data, right? That's what this particular scenario is for. Rolling out a new application, right? Or if you have something wrong. So right now, where a blue-green demo is still blue, right? The developers have made a patch and they've rolled it out to GitHub, and I wanted to flip it over to a new environment, right? I come in here and I select my route again. I tell it to go to my green demo, save, and now if I go to my green demo, that's not it. Or back to my publicly facing one, and now I have a new application online, right? And you just keep doing that. It's continuous integration, continuous development, right? So say the developers have a new patch that they want to put out. They put their application up on GitHub, and this is a very simplistic demo, right? But it translates, right? So I'm right now the application developer, and I'm going in and I'm making a change to my code from version 1 to version 2. I make my commit to my green branch. I come back out here, and right now it's set for the green demo, right? But he's still at version 1. Right? OpenShift doesn't do anything with it right now because I don't have it hooked to any of the cool little tools and stuff like that. So I come in here and I tell it to do start a build. Right? You'll notice down here in the bottom right hand corner, you'll see it as it starts to go and it does the get. Right? He's going to check for a container image. Right? He's going to pull, he pushes. Now he's rolling back the old one, and he's going to roll forward the new one. Right? Scale that down, and he's going to get rid of it, right? Don't need that image any longer. So now, in theory, right, our blue-green demo should now be V2. And in principle, that is one of the coolest things I think I've ever come across in as far as infrastructure, right?
Sure.
So I, in theory, just rolled out a whole new application without tearing anything down, without disconnecting anything. You have a whole new application that you can present to your end users, to your customers. And
So
in
as
the
long as you
meantime,
containerize like a big project with lots of inputs to individual containers, each one of those can be developed simultaneously, just updated as
Yeah.
needed,
Yeah.
rolled back as needed. without needing
So the thought process behind the container is you don't necessarily want to do a lot of hard coding in the container itself. You want those external source control, that GitHub, GitLab, Subversion, ClearCase, ClearQuest, whatever it is that you're using. you want to take that base image, and this goes back to the layers, right? I want to layer on the applications. The next piece is I want to layer on the database connections, or have a separate container that does the database connections for you, and then those two will interact, right? So it's everything in layers, and you don't want to hard code that into your container images. Otherwise, every time that you do an application rollout, you have to do a Docker pull, modify the container, a Docker save, Docker import or push into the registry, and then you have to get the whole image, and you have to roll that image out, right? Is that the best way to do things? Maybe in some cases, right? But it would be preferable if you didn't, right? And that you use your source control, right? So that you're pulling everything down. That way you don't have to, he didn't actually go out and pull a new HTTPD image. He just used the one that was local to him, and he pulled down the new get information, layered it up, and pushed it out, right? That's the coolest thing, I think, with containers, is that particular function.
One thing I'll add on to that too, so if you say you have multiple environments, dev, test, prod, pre-prod, whatever you have, you would want to write your code and variabilize as much as you can. So like the database is at this variable. And then when you do your deployment in each environment, you would define what that variable is. This is non-prod Postgres, what he would connect to. And that way, again, you could have like a single source of truth in Git.
And then that's where you get into the, if you're specifying there are, let's see, your environments, you can add these config map secrets and stuff like that, so that you can tell it, you know, in this environment, this is this variable, right? And then it will, if you have a separate database connection, you have those config maps for each individual string, and that particular application will talk to that set of systems, right? All right. So I got all excited about this particular scenario earlier, because for me coming from a you know, an infrastructure sysadmin, you know, I'm accustomed to rebuilding applications, stripping things out, adding things in, you know. I didn't change any of the infrastructure, none of it, right? All I did was just use the tool that was, you know, that was available, and I could roll out a whole application. So we also have another, and let me explain something about this Git that I've been doing, if I can find it again.
While you're doing that, it's also worth mentioning that you have a very simple application here. It's Apache with a little bit of code layered on for your index.html probably. That whole thing, which on there is like 30 megs, maybe 8 megs, I think, on the other one. And you compare that versus a VM, like you're never going to create a VM with 30 megs. Right. 4 gigs, 8 gigs, 16 gigs, whatever. This is serious consolidation to the point where, I mean, the max you can run on a node is 250 pods, but you could probably run more than one node on a physical piece of hardware. Like even a cheap piece of hardware should be able to do, you know, thousands of containers, depending on the containers, of course.
Yeah. So this is what I was telling you about earlier, right? So I labeled these green. You have one for master, one for orange. And you can promote your changes all the way up, right? Have as many of these branches as you want, so that your individual users can manipulate that specific branch. They can do pull request on that branch, modify their code, and then put it back in, so that, you know, whoever your application engineer is can do a merge to master, and that would be the one that you would deploy. And all the while, they're still making commit changes to the other applications. They're still live. They're still pushing out changes. You know, everything is going on in the back end, but nobody on the front end is any more aware of that than anything. And that's what those routes are for. This route here is Bluegreen demo. that gives you access to your master branch or whatever branch you're on, and everything rolls from there. So let's talk about the differences between projects. So you can come in here and you can make a new project. So say you're now off of doing whatever HTTP stuff that you were doing, and you wanted to come in here and you wanted to make a Jboss instance, right? So either you could play with it or, whatever, right? I don't want to affect what I'm doing in the one project, right? Because that's up and stable and people are using it. I create a new project. I come in here and I select this. I'm going to just use the quick start, right? It's going to go through the build process. Down here in the lower right hand corner, it's going to tell you what it's doing. Right now it's cloning that particular GitHub, and it's going to pull it down here in just a second. Right? And I've not done anything to the infrastructure, just created a new project, and I have a new application. Right? This goes through and it abstracts a lot of things, so you can set your persistent volumes. So if you have a Gluster backend or a Ceph backend, or even NFS is not recommended, but you can set your persistent volume group to that, right? So if somebody does come in and they have a database container that needs that persistent volume, that's every time that container goes away and they want to reattach to that specific data store or whatever, you can make that persistent volume, and then every time you start that container, you give it that volume name and it will reattach it, right? But it will abstract that from you, right? So if you don't necessarily have to have developers that need to know that storage space is there, you can give it out to them, I want to say as a not a secret or a service. But it will reattach back to that same data source, right? Or you can reattach another container to that same. It's persistent across removal or scale downs or anything like that. The same way it is with networking and stuff like that. I haven't gone in and done anything with networking. You haven't seen me in there typing away, giving it ports or anything like that. It's all kind of default. So it abstracts a lot of those layers away from your developers so that they don't have to worry about it or think about those things, right? All they have to concern themselves with is just the application. They don't care.
So large you run all those pods in the same instance, or?
No.
No, it's all scaled across. So what ends up happening on the back end is that OpenShift stands up a software-defined networking service that actually allows pods to speak to each other within a project by default. They're all given. So we talked about routes. Did you want to get into services, or do you want me to talk about services?
Yeah, you can talk about services.
So when you stand up a pod, the actual network, so like say listen on port 80. So port 80 would have a service attached, that is, it gets a name. Anybody can call that name. So if you wanted to talk within like pod to pod, you wouldn't need to know, go to 172 dot whatever. Right? If you go to my application, this service, which runs on 8080. The nice thing about that service is on the back end, it's actually a load balancer. So anytime you talk to that service, it's going to balance the load on all the pods behind based on whatever criteria you specify. So it could be like a more of a sticky thing if you need that, or round robin or whatever it is. OpenShift will make sure that the traffic gets to a pod. And then that service is the thing you can call, and you can also then attach a route to the service, and a route is the externally facing network piece.
Okay.
So we have a highly available setup of routers in there that will handle all the traffic in an HA way, and then send that down to services where we handle it in an HA way. And all that traffic stays internal, so you're not going out and doing firewall requests and all these sorts of things. You're just making sure that typically your standard ports like 443 and 80 are open to OpenShift, and you're usually pretty good. And you can use those services as like an end tier if you're into that sort of thing, like the app web DB, and control all that traffic within OpenShift as well. One of the things that typically we have to have lots of conversations around when developers start getting into OpenShift is being cloud native by design. So there's a buzzy kind of 12-factor cloud app, which is like be stateless, or outsource the state management to something else. All these different rules, so that we're trying to say that any pod is disposable. You can spin them up. You can spin 10 of them up. Doesn't matter. Traffic increases, you can scale horizontally. And then in the future, we're also looking at vertical scaling, which will be neat, but that'll be a 4.0 kind of, 4.x I should say, feature, where if you need to scale your pod larger, you can also do that.
What's the left taking?
All right, I had to do a
Say again?
little cleanup.
I said it's left taking.
Oh, yeah.
It seems like all of y'all are, well versed in the entire.
Well, actually,
I am not an expert in this.
So I only started mucking around with OpenShift in January, or
Yeah, just
maybe
this past 6-8 months.
6-8 months. There is a large learning curve, right? The vernacular is different on the back end than it is like infrastructure type stuff, right? But once you start that translation process, it's kind of like learning a new language, right? Everything kind of seems jumbled, and then once you start understanding the foundational words and they repeat, then it starts making a lot more sense. Is it perfectly clear for me? Absolutely not. I've been mucking around with it for 6 months. All right, so I had to do a little cleanup because I'd already run through some of this stuff. I did a little cleanup, and then now my pod's deploying, right?
It's worth noting too that it's a light blue right now.
Yeah.
So one of the things in this, a light blue means the pod is started, but it has not necessarily passed the readiness checks. So say you have a really complex application that takes a minute to boot up, you would have some sort of an API endpoint that would register okay when the full application is ready to start processing traffic. Give it to this to let it know to check that, and when it reaches that criteria of okay, then it'll go the dark blue. It will not send traffic to that pod until it is dark blue.
Okay.
So that you could, if you're going to talk about scaling or all, I don't know if you want to demonstrate that. That's where it becomes important.
Yeah. So I don't have the capability to scale with just the minimal trial that I'm on. So if I can ask it to, and here in a second it's going to give me a quota limit reached.
Yes.
Right.
So for all intents and purposes,
But if
scaling is that simple.
But
Just
if-
by hitting the up arrow, you double your capacity for processing.
Service stays the same, route stays the same, but now there's 2 pods.
right.
Okay.
If you want to see that function, you can come over to my desk. I have a POC, and I'll show it to you.
All right.
It can auto scale too.
It can,
Nice.
based off your quotas. So if you have a quota that sets the memory at a certain limit, so like if you have an ingestion and then a running application. So say your ingestion, starts to get flooded. People are putting stuff on there with that max memory or max CPU quota. You can tell it, all right, so I need to scale out to 10, right? So as it's coming in, it'll scale that out. And then as soon as those quotas are underneath, it'll scale back down, right? So that you're still maintaining your footprint, your presence, but you don't necessarily need as much compute, right?
Gotcha.
So this is the actual application that where did I go? Go back. Right? So I asked for it. There was a GitHub. Somebody has already put together this, but it doesn't necessarily mean that you can't substitute your own Git, right? And then just like that, you have a running application just sitting out there waiting for you to utilize it, right? And that pretty much is for the open, the entry level, that's pretty much about it, right? I would highly recommend that you go out and take a look at it and play with it. You can do the upstream version, which is OKD, from the OpenShift, the product, and then give it a run. You can set it up on your laptop. You could do a single node cluster, right? Requires DNS to be set so that you have those. What makes all of this function behind the back end is there's a DNS wildcard set for the base application that the OpenShift will utilize to present your apps to, right? So that's all you need really is IP space, DNS entry, and that wildcard to make it run. That's pretty much it. Anybody got any questions?
Yes, you said in the beginning that OpenShift wants to be connected to the internet.
Yes,
Can you do
it
it
does.
without the internet?
You can do it without the internet. It is on an order of magnitude more difficult to do it as a disconnected environment. You have to make sure that you're pulling down all of the containers, not only for the infrastructure, because with OpenShift it uses containers itself to host services internal to itself, right? So your routing, your networking, any of your back-end storage, if you have disk storage that you're presenting to it, or container native storage, those all need containers or images to run, right? So if you're doing it disconnected, you have to pull down everything for the infrastructure, and then you also have to pull down everything for your source to image builds, your optionals, all those containers have to be pulled down and populated into an internal registry prior to starting, right? Otherwise, the deploy will fail, and then if you don't pull down the correct images and place them in the right namespaces on the install, it will fail. If you don't place the additional images, what you see here in this catalog, those are additional, right? So they don't necessarily have to be there for you to do the install. But whenever somebody comes in here and they want to click one of these, it'll fail, right? And so those have to be there. Yeah. So it's a little bit different to do a disconnected install, and that's why I say that it wants to.
So it may not be the best thing for like a JWix or Simran.
No, I mean it could be done.
Definitely on it.
Yeah.
I've done lots of disconnected.
Yeah.
It's just like you mentioned, it's a little more preparatory work in that you just have to make sure you download all the necessary bits to get started, and then same with upgrades. You'll want to pull down the latest stuff. But I mean, any place that's disconnected already has some sort of workflow where they know they have to pull content in.
Sure.
So it's just like one more step. You say, hey, we download all the latest RPMs. Oh, and plus we download all the latest Docker images, right? One thing I wanted to touch on too is like what problem this is trying to solve. So for me, talking to a lot of developers, at least a couple years ago, everybody was like doing Docker, right? They wanted to containerize. And still, depending on where the customers are in their kind of their journey, they may just be getting to that point where they're starting to containerize. And that obviously that problem was trying to solve the SOP on how to build your application and getting all the dependencies. And it's a pain in the butt for the ops guys. It's a pain in the butt for the developer guys because they're going back and forth trying to figure out, no, it's version X of this or whatever. So containers obviously made deployments a lot easier. The problem became for the ops guys when you say, hey, here's a Docker image, go put this in prod. How do they like monitor to make sure that container is still running? How do they scale it out? All of these different things didn't really make sense. So then you'll see people being like, okay, well, I'll use Docker Compose or Docker Swarm. And that gets you somewhere. That actually is a good step in the right direction. But eventually all of them realize a point too where in that Docker Swarm, they're like, this has some cool features, but it doesn't have things I need, like the storage and the routes and all of these different pieces. And so then they're like, okay, well, maybe I should look at Kubernetes. I learned Kubernetes before I learned OpenShift. It is so much YAML. I mean, every one of these things that he's doing in the UI is like another YAML thing you've got to write up and get the formatting right and push it in. You can absolutely DIY it if you have a subject matter expert army in writing YAML for Kubernetes. What OpenShift does is kind of twofold. It gets rid of a lot of the need to write YAML. You can still absolutely do it, but it gives you a UI and a command line interface that makes it a lot easier. And it also adds on the features that you want, like handling all the storage. So, like if you deploy this in Amazon or on OpenStack or whatever else, VMware, it will automatically create the storage and attach it to a pod. It has those hooks into the upstream providers. It does a lot of fun things, and Kubernetes may do this as well, but you mentioned the Bluegreen deployments. You can do things where you say like new git commit, automatically do a rebuild, spin it up, send 10% of the traffic to the new application.
Yeah.
If I don't get any phone calls in a couple hours, go ahead and shove the rest of the 100% of the traffic over, or the rest of the 90%.
So this seems to be like a dream operation for a DevOps team that's kind of agile.
Yeah.
And
Constantly running.
yes,
So the YAML is not gone.
there's the
The YAML is still present,
Yeah.
but it's pre-populated by OpenShift. That's the orchestration bits. Right?
Yeah. So it's quality of life improvements. And to your point about the CI/CD, the other thing that we do at almost all our deployments is we end up putting in a CI/CD pipeline, such that a git commit happens, and then say they have to run Fortify or OpenS cap scans or run it through Twistlock, whatever it is. We go ahead and have Jenkins run those things, and if it passes the test, then move on to like whatever next step that might be, which may be promoting this image from dev into your test environment. Because we're only going to do our build once, and then we're going to shuttle that image all the way through till eventually it hits production. So your security guys, I've had them come to me and say this, like, we want to SSH into all your production pods and do security scans. And we can turn around and say, you don't need to. You can test those back in test. And we are 100% sure that the same pod that was tested in test is the one running in production. They're all ephemeral. They're all immutable for most intents and purposes. So what's in test is going to be in production.
Unless somebody's modified that image.
Which you would really have to go out of your way to do. And the second anything happens, like a scale down, scale up, like it's all gone.
Yeah. I did want to show you a little bit of this quota stuff, right? And the quotas work both ways, right? Keep you from overutilizing the system, right? You don't want people just going in there and spinning up 10,000 pods or containers, right? So
Magic.
Yeah.
That would work.
So the containers or the quotas do work, right? So this particular thing is set me as very few pods and memory utilization, and right now it's refusing to build because I'm at my memory limit, right? So this one pod in here, and he's refusing to build. He's not going to continue because I've met my quota, right? And those are important business functions, right? Knowing who's utilizing, what and how they're utilizing it, right?
The other thing that's worth mentioning is that these are not pets. So when you do maintenance and you say like, hey, take down this node, the pods that are on that node are going to be killed and restarted on another node. They're not migrating. It is 100% kind of the cattle version of the pets versus cattle. And developers need to be aware that we do not necessarily, we being like Kubernetes and OpenShift, we don't guarantee that any single pod will live. We guarantee that what you define the state will be, it will do its best to maintain. If you say have 2 pods, it will always try to maintain 2, but it won't necessarily be the same 2 you started with. If one dies, it'll kick another one right back up.
Yep.
If the node goes down, it'll just start it up on a different node.
Yep.
That's fascinating.
Yeah, it is very fascinating. It's an awesome product.
It's fun and it's got a sexy UI.
Tell me about my sexy UI.
Yeah, I love it. I love
Still
this
recording.
video.
Still recording.
I think
That's okay.
That was mostly for Travis.
That pretty much closes out the lunch. We'll call it
And
in there.
All right.
Thanks for showing up. Yeah, I hope you have a good day.
Very cool.